So you've seen polynomial long division, and at this point you're probably saying, man, that process takes too long. And then if I screw up, I don't know till the end. Thankfully, there is an easier way to do it. It's called synthetic division, and it takes all of 3 lines. So you don't need all the different lines of polynomial long division, just 3 lines of synthetic division. Then we're going to take a look at something called the remainder theorem, which is also a shortcut of sorts and can tell us the remainder just like that. Let's take a look. Now the nice thing is, there's a shortcut to this. It's called synthetic division. And it does the exact same thing. The only thing is, it's a lot faster. We still need placeholder zeros. We still need everything else. We're still going to be doing very, very similar things to long division, but so much faster. And we're just relying on the coefficients here. So if I take a look at this one, I know I have the coefficient 1 from my k to the third. I know I need a 0, k squared. I know negative 4k plus 13. So the 1, the 0, the negative 4, and the 13 are all coefficients. So here's how I'm going to set up my long division. I'll use the 1, the 0, the negative 4, and the 13. Over here in this box, I'm going to take whatever this is, flip it, so it was a positive, now it's a negative, and add it in there. Now, the first thing that we always do in long division is you always bring down the first one. Whatever the first number is, you bring it down. Here it happened to be a 1, it's not always. And what I'm going to do now is I'm going to do whatever's in this box times this number. I'm going to put it here. So, well, negative 3 times 1 is just negative 3. Then I'll add these numbers together, and the result goes here. So, 0 minus 3 is negative 3. I'll do the same thing. I'll do this negative 3 times this negative 3. I'll put the result here. Well, negative 3 times negative 3 is positive 9. Negative 4 plus 9 is going to give me a positive 5. Then I'll do the same thing. I'll take this negative 3 times this 5, and I'll put the answer here. Well, negative 3 times 5 is negative 15. Then I'll add these two together, and I'll put the answer here. Well, 13 minus 15 is just negative 2. Yep. Negative 2. So, my first step up here was to remove the variables. I'm going to throw them back in. So it's going to be 1k squared minus 3k plus 5. And then this is our remainder of plus negative 2 over k plus 3. The same answer we got before, but a lot less math. Let's take another look with synthetic division. So this one says polynomial long division with missing terms. We can totally still do it with synthetic division. And we'll do it a tiny bit faster. So I know that this is 1x squared minus 1x cubed minus 1x squared plus 0x plus 3. So we're going to have 1, negative 1, 0, and 3. This is going to change to a positive 1. Set it up. Bring down the first. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 0 plus 0 is 0. 1 times 0 is 0. 3 plus 0 is 3. So the answer to this one is just 1x squared plus 0x plus 0 plus 3 over x minus 1. You can just rewrite this as x squared plus 3 over x minus 1. We were able to do that really quickly just using synthetic division. It's okay if all of these zeros appear. That's perfectly fine. If you're ever unsure of an answer, go check it in Desmos, just like we did with the first one. That way you know you're right before you hit submit on Delta Math. So the remainder theorem says that if we flip the sign of a divisor and plug in a constant, we can find the remainder. The divisor is always just this part right here, what we're dividing by. Now let's take a look at an example. We saw this problem before. This was the first one we just did with polynomial long division, right here. And we got this answer after that long exhaustive process. The remainder theorem is a nice way of showing or finding just the remainder, just this 2. And we can do it by flipping this -5 to a positive, whatever the sign is, you flip it. And then for every instance that you see an R here and here, 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 and here, we're just going to plug in +5. So let's see. I'm going to take this. So that means I'll have 5 to the power of 3 minus 7 times 5 squared plus 13 times 5 minus 13. You might be looking at this saying, Mr. Gallagher, I have no idea how the heck I'm going to do that in my head. And I do not expect you to do it in your head. You can just head on over to Google, type it in, and Google will give you the answer, which is 2. Which is great, because that's the exact answer we were expecting way up here, a 2. Now, we can try it with this one. If f of x is equal to 2x to the 4th minus 1, then what's the remainder when f of x is divided by x minus 1? So, first step is we need to switch that to a +1. Okay, second step. I can't spell. Is we plug in. So we're going to have 2 times 1 to the power of 4 minus 1. Well, plug this into a calculator, your phone will work, Google will work, anything like that will work. The answer here is +1. Which means that our remainder, when 2x to the 4th minus 1 is divided by x minus 4, the remainder will be +1. If this was a negative, your remainder would be negative. If it's positive, your answer is positive. And this is actually really helpful, because if the remainder is 0, then it's an exact factor, because then it goes in evenly. If you have a remainder, whether it's positive or negative or what have you, it's not an exact factor. So you've seen synthetic division, you saw the factor theorem, the remainder theorem, and you've tied it all together with polynomial long division. Now, time to give those two a shot in Delta Math. After that, just make sure to go back, do the summary on Google Classroom, read section 1.6 in your textbook, and just complete the reading summary there. You can do the reading summary as many times as you want. That way, you get full credit for it. Thank you very much, folks. If you have questions, see me in office hours, and have a great day.